Hello, everybody. Welcome to one more exciting session in the series AWS Bootcamp. In this particular chapter, we'll discuss about AWS networking with the help of VPC. We'll discuss couple of components in VPC like CIDR, and we'll understand different VPC terminology. We'll discuss about internet gateway and about security groups versus NACLs. We'll discuss about NAT gateways and route tables. That would be the agenda for this particular session. Now let's start with a VPC. A VPC is called as a virtual private cloud. Now, what is the use of a VPC? A VPC, you can call it as a secured, isolated private cloud hosted within a public cloud. So that basically means now AWS is a private cloud, right? Like anyone who has an AWS account, they can connect with the AWS cloud and start using the resources on AWS. But let's say if I'm using AWS cloud for my organization, I don't want anybody else who is there on AWS cloud to have access to my services. Then what I will do on AWS, with the help of a service called as VPC, we can create our own private cloud. That is the use of a VPC. You can basically say a VPC, it closely resembles a traditional network that you operate in your own data center. Like in your own data center, you create a network, right? Similarly, by creating a VPC, you can create your network. You can create subnets, you can create routing, you can work with gateways, you can peer the connection, you can monitor the traffic, right? There are a lot of things that you can do once you create a VPC. The first step is that you have to create a VPC to make sure that your services are there within your private cloud on the public cloud, that is AWS. So to make or to create a public cloud, or sorry, to create a private cloud for your organization on AWS, you can use a service called as a VPC. A VPC, what customers can do, they can run code, they can store data, they can host website, they can host applications, they can create databases, or else they can do anything else that would do in an ordinary private cloud. In an ordinary private cloud, what all things that you can do everything inside a VPC. But only difference is that a private cloud is hosted remotely by a public cloud provider. Okay. VPCs combine the scalability and convenience of public cloud computing with the data isolation of private cloud computing. So with the help of VPC, you can make sure that your services or your computing resources on AWS are isolated with the help of a service called as VPC. So on public cloud like AWS, by using a VPC, you can isolate your resources. Now let us look into some of the terminology that is there on AWS VPC. First one is called as internet gateway. Okay, we'll discuss about internet gateway. With the help of internet gateway, we can give internet access to a VPC. Okay, we'll discuss that. And there is something called as NAT gateway. If you want to give a partial internet, there's a VPN gateway, customer gateway, there's a VPC endpoint. Okay, there is something called as a route table, DX locations, NACLs, VPC flow logs, VPC peering connections. We'll discuss about all these terms one by one. Okay, so the picture here will be able to explain most of the VPC terminologies. Now, first of all, let us look from here. Now, a user, you're getting a request from the user from the internet. Where it goes first? First, it will go to a internet gateway. So the VPC, okay, the VPC should have an internet gateway. So internet gateways are assigned for a VPC, not for a subnet. A internet gateway is assigned for a VPC. Now, once there is an internet gateway for a VPC, that means this particular VPC now has internet access. If there is no internet gateway, that VPC will not have any internet access. Okay, so we have to create a logical component. So by default, if it is a default VPC, by default internet gateway will be there. But if we are creating our own VPC, it is very mandatory that we have to create a internet gateway and assign the internet gateway to a VPC. We will do that in our practical session. We will create internet gateway and assign that to a VPC. Once there is a internet access to this VPC, once a request coming in, now let's say in a VPC we can also create a subnets. Let's say these are two subnets which are there. One is a public subnet, one is a private subnet. So for this VPC, there are two subnets. One is a public subnet, one is a private subnet. Now, what is a subnet? Now, we can say a subnet is a range of IP addresses in your VPC. Okay. Okay. And when you create a VPC, okay, depending on how you want to configure your VPC, subnets can be considered either a public subnet or a private subnet. Now, what is a public subnet? The subnet traffic is routed to the public internet through an internet gateway. Okay, like for example, let's say if you're hosting a website on this particular EC2 instance, which is there in this public subnet. Now, it should have a public access, right? So, with the help of internet gateway, this public subnet will have a internet access. Now, let us say if you are creating a database server, okay, now your database server, should it have an internet access or should it have a public access? No, I don't want to give my database a public access, right? So if you don't want to give a public access to any server, you can basically put them on something called as a private subnet. All right, so basically a request will come to the VPC through an internet gateway and there is a route table. So first of all, whatever request is coming in this route table, it will check whether there are valid permissions or valid routes for it to divert the traffic. If there are routes that are added to the route table, it will send to that particular subnet. Okay, there are two types of subnets, public subnets and private subnets. All right, let us recap this couple of terminologies that we have used. We have used a term called as internet gateway. What is the use of internet gateway? The use of internet gateway is to make or a VPC will get an internet access. Okay, if there and the internet gateway is assigned to a VPC. Okay, and inside a VPC we can create either a public subnet or a private subnet. Okay, and inside a subnet you can have virtual machines or any other resources from AWS. All right, and there is a route table. In a route table we add routes to make sure that the IOs are sent to the respective EC2 instances. Okay, now let's say that this EC2 instance, if it has to store the data in S3. Now this EC2 is there in a this VPC, but this S3 is not there in VPC, right? Then how we can allow this EC2 to store the data in this S3? We can use something called as a VPC endpoint, so that the S3 bucket no need to be there inside this VPC. With the help of VPC endpoint, we can store the data in S3 from EC2. That is the use of a VPC endpoint. Similarly, with the same VPC endpoint, we can also configure monitoring in CloudWatch. So it is also very important for us to do the monitoring of the resources. So with the help of VPC endpoint, even the CloudWatch is not there in this VPC, we can configure monitoring with the help of CloudWatch. Okay. Now let us say my application is spread across cloud plus on-premises. Now on-premises, I have one server. On AWS, I have one server. Let's say this is a database server. This is a web server, for example. If I want to establish communication between these two servers, we have to use couple of components. One component on AWS side is called as a VPN gateway. That is the service that is used to allow communication of this EC2 instance outside AWS network to a client location, the server which is there in a corporate data center. And on the data center, there should be something called as customer gateway. So with the help of these two, we can configure a secure VPN connection so that data can be transferred, or these two servers can communicate. That is the use of VPN gateway, customer gateway, which is there on AWS and the customer side. Now there is also one more way. Okay, there is something called as a direct connection. What is a direct connection? So now from AWS data center to your data center, we can lay a physical cable. Okay, if you're using a physical cable also, your communication should happen go through the VPN gateway. All right. So a couple of terminologies that we have discussed till now. One is internet gateway to allow internet access to the VPC. Every VPC should have one internet gateway if it has to have a internet access. For default VPCs, the internet gateway is by default assigned. If we have to create a if we create a new VPC, we have to assign the internet gateway. Okay, there is a router. In the router, we add the route tables. In the route tables, we add a route. Okay, and we can create public subnets which are available for public, private subnets which are not available for public. And there is VPC endpoint which will give EC2 access to S3 and CloudWatch. And there's a VPN gateway which can help to establish communication between the customer data center. And there is direct connect connection which will help establish connection to the customer data center by a physical cable that is laid. All right. Now let's say there is two VPCs. Now VPC 1, VPC 2. Obviously, this is a private cloud by itself and this is a private cloud by itself, right? If we want to establish communication between the devices which is there in VPC 1 and VPC 2, we have to create something called as VPC Peering connections. It will help us to establish communication between two VPCs. All right. So let us look into these components. By end of this networking session, we will do all these components. We will create all these components. We will do hands-on exercises of all these services. All right. Now let us discuss about a couple of more important components like CIDR, how to give IP address to these components and all. Okay. Now what is CIDR? CIDR is called as Classless Inter-Domain Routing. Okay, CIDR is a method of allocating IP addresses to the resources which is part of that particular VPC. Now, CIDR is used in security group rules as well and in all the AWS networking in general. Okay. Now, CIDR will help us to define the IP address range. To explain this better, let me switch to my whiteboard. Okay, let us discuss about CIDR. Now, let's say an IP address looks something like this, which is like 10.0.0.0. This is basically IPv4. Okay, that means it basically has 4 octets. Okay, each one of them you can call it as 1 octet. Now each octet is capable of 8-bit size. Okay, each octet is 8 bits means basically it is capable of giving addresses from 0 to 255. Okay, but first of all, let us count this. So 8 bits, 8, 16, 24, 32. So totally it is a 32-bit IP address. Okay. Now, I want to allocate, let's say I'm creating one VPC. Okay. I'm creating one VPC. to the VPC, I have to mention what should be the IP addresses that whatever resources that you're creating in this particular VPC. I'm giving an IP address saying that 10.0.0.0. Okay, if you create one EC2, if this IP address is coming, if I want to create another EC2, how it will take IP address? We can't define all the IP addresses, right? So we can define something called as a range. Okay, we can define a IP address range. Let's say if I'm giving an IP address range as 16, okay, that means 10.0.0.0/16. This is a CIDR notation. So what is the meaning of this giving 16 here? That means we are saying block these two octets. So each octet is 8 and 8, right? So this is reserved. This will not change. Now if you are creating anything under this VPC, this will get an IP address 10.0. It can be 1.0. Because I'm saying 16 should be reserved. That means this 2 can change, right? So this 2 is capable of how many numbers? 0 into 255, from 0 to 255, and 0 to 255. So total how many IP addresses will I get if I give the range like this? I can get 255 into 255. So many IP addresses can get out of this IP address range. Now let us say I'm giving an IP address range to a VPC, which is like 172.0.0.0/24. That means what? I'm reserving these 3 octets. That means these 3 octets IP address will not change, because I'm giving the CIDR range as 72.0.0/24. That means 24 bit should be reserved. Only this I can change. If I'm creating any EC2 instance in this VPC, it will get 172.0.0.1. Second, if any other resource, let's say 2, 3, 4, etc., it will go up to how much? This octet is capable of 0 to, from 0 to 255, right? So it can go up to 3, 4, 5, etc. to 255. So totally you can get up to 255 IP address in this range. Now if I'm giving an IP address range as, for a VPC, if I'm giving an IP address range as 164.0.0.0/8. Okay, that means only this bit is reserved. 255 into 255 into 255. So many IP addresses will come with the CIDR range. So basically, you can say, what is CIDR? CIDR, you can also call it as, it is basically called as super netting. Now, it is a method of assigning internet protocol address that improves the efficiency of address distribution and replaces the system based on class A, class B, and class C networks. Okay, that is the basic use of CIDR use cases. Okay, to use CIDR to give IP addresses. Okay, I hope that was clear. Now, if you see the example here, uh, you see there is a www.access.yyz/32. So how many IP addresses will get? It will get only one. Now, if you use 0.0.0.0, full addresses we can get. Okay, if you give /26, how many our IP address bit you can get? You can get so many. That is how you define IP address range. So inside basically there are two components. One is called as base IP. Second one is called as subnet mask. Now a base IP represents an IP contained in a range. But a subnet defines how many bits can change in the IP. That is what we have discussed. /80, this many IP addresses will get. /16, this many IP addresses. /24, this many IP addresses. /32, you'll get only one IP address. That is how you can define CIDR range. I have explained you guys only by using 8-bit, 16-bit, 24-bit, and 32-bit. But if you want, you can reserve uh, any number of bits. Okay, you can reserve 20 bits, you can reserve 24 bits, you can reserve 16 bits, 18 bits, 19 bits. So based on how many bits you reserve, you see this is the how many number of IP addresses you'll get. If you reserve 8 bits, this many number of IP addresses will get in that particular range. Okay. If you reserve 21 bits, you'll get 2048 IP addresses. If you reserve 15 bits, you get this many number of IP addresses. That is how IP address range will work with CIDR. And again, there are two types of IP addresses. One is called as public IP address. Second one is called as private IP address. Both are IPv4. Now, the Internet Assigned Numbers Authority established certain blocks of IPv4 addresses for the use of private and public internet addresses. Okay. Now, out of them, for a big networks, we can use 10.0.0.0.0 to 10.255.255.255. Those are something that you can use for private IP. Now, AWS default VPC IP addresses starts with 172 dot 60 dot 0 dot 0, and you have a slash 12 as a CIDR range. And normally for the home networks, it is 172.168.0.0. And all the rest of IP addresses on the internet are public, except this range, rest all are public IP addresses. What is the difference between public and private? Public IP addresses can be accessed by public. Private IP address only access in that particular private network. Now we will create a VPC in a bit. Now before that, there are a couple of points that we need to understand. All the new AWS accounts have default VPCs. If you create an AWS account, by default, every region will have some default VPCs. I mean, if you launch any EC2 instance, by default, it will choose a default VPC. Okay, default VPCs has internet connectivity. That means a default VPC, there's an internet gateway already created and assigned to that VPC. And we can also get public and private IPv4 DNS names. So if you create one EC2 instance, you will get one public DNS name or a public IP address, and you'll get one private IP address and private DNS name. All right. So you guys, when you have created EC2 instances, we know that every instance got one public address and one private address. Now, before let's discuss what is the hands-on exercise that we'll be doing in. Now, let's say in every region there will be a VPC. Inside a VPC, as I told you, we can create a subnets. A subnet can span across multiple availability zones. There can be two types of subnets. One is called as public subnet. Second one is called as private subnet. Okay, let us finish that and do the hands-on exercise. Now let us say AWS reserves 5 IP addresses. I told you that every optic has 0 to 255, right? Out of that, AWS reserves 5 IP address, first 4 and last one in each subnet. In every subnet, it reserves 5. These 5 IP addresses are not available for use and cannot be assigned for any EC2 instance. So whatever IP addresses that a subnet is reserving, you cannot use it for anything else. Okay, now in the CIDR block, if the CIDR block is 10.0.0.0/24, now what are the reserved IP addresses? 10.0.0.0 is reserved for network address. 10.0.0.1 is reserved for AWS for the VPC router. And dot 2 is reserved for AWS for mapping into Amazon provided DNS. Dot 3 is reserved for AWS for future use. 255 is used for network broadcast support. And AWS does not support broadcast in a VPC. Therefore, this address is basically reserved. So basically, there are 5 addresses that are reserved, and this is the use of all the 5 addresses. Now we were discussing about internet gateway, right? So now what is an internet gateway and what is the use of that? Internet gateway allows resources in a VPC to connect to the internet. Very simple. It allows horizontal and highly available and redundant it must be created separately from a VPC? No. If you're creating a VPC, by default, internet gateway will be created? No. You have to separately create an internet gateway and assign that to a VPC. One VPC can only be attached to one internet gateway and vice versa. So only one internet gateway you can assign to one VPC. There is no use, right? Why to have two internet gateways? Because the work of internet gateway is to provide internet access to the VPC. So one is more than enough. Now let us say the region, there is a VPC, there are subnets, public subnet and private subnet, and to the VPC we assign the internet gateway. Internet gateway is assigned to the VPC, not for subnets. Now, how the traffic will flow? There will be a router and there will be route tables. In the route tables, there are routes that are added to make sure that communication is established properly. Okay, there is internet gateway, there is router, there is a routing. Now there is one special type of host called as bastion host. Now a bastion host is a server whose purpose is to provide access to private network from an external network such as internet. We can use bastion host to SSH into private EC2 instances. The bastion is in the public subnet, which is then connected to all the private subnets. Bastion host security group must be tightened. If you look here, we can easily understand. Now there is one public subnet. Inside a public subnet, we create something called as bastion host. Now inside private subnet, I have multiple EC2 instances. The user, if they wants to connect to this instance, first they have to log into the bastion host. From the bastion host, they can log into any of these particular servers. It is a secured way of connecting. Okay, that is the use of bastion host. Now the security can be established in two ways. One by using security groups, second by using NACLs. Now what is the difference here? An NACL is assigned to a subnet. Okay, an NACL is assigned to a subnet, and in NACL there are inbound rules and outbound rules. So this will filter the traffic and then sends to the subnets. Okay, let us discuss more about NACLs, which is called as Network Access Control List. Now this is an optional layer of security that acts as firewall, controlling traffic in and out of a subnet. So as I told you, NACL is assigned to a subnet. So it is like a firewall. Whatever traffic that is coming to the subnet, the NACL will basically make sure that only allowed traffic will enter inside. One NACL per subnet. New subnets are assigned with defined NACL. So for one subnet, we can only assign one NACL. Newly created NACLs will deny everything. So by default, AWS goes with least permissions. So newly created NACLs will deny everything. Now NACLs are great way of blocking a specific IP address at a subnet level. Now let us say I don't want to receive any request to subnet from certain IP. It is great if you use NACL in that scenario. Now couple of more things about NACLs. First rule match will drive the decision. Let's say we have updated 2 or 3 rules in NACL. Whatever is the first rule, that will drive the decision. And every rule will have number, higher precedence with a lower number. So the lower number will have higher precedence. The last rule is an asterisk and denies a request in case of no rule match. The last rule, basically it is to deny if there is no rule that is matching. AWS recommends adding rules by increment of 100. That means one rule number 100, second rule number 200, third rule number 300. In that way, it is better to define your rules. Now, if you look into this picture, there are two subnets. Okay, one is a public subnet and second one is this is a public subnet and this is a private subnet. If you see, For each subnet, there is one NACL that is assigned. Okay. So for every subnet, there will be one NACL. Now, a default NACL accepts everything inbound slash outbound with the subnets it is associated with, and do not modify default NACL, instead create a custom NACL. So basically, if you want to add some rules, better you create a new NACL and add it. As I told you, the rules will be like 100 increments of 100, and you can either allow them or you can either deny them. This is how basically a rule will look like. Okay, and let us discuss about couple of ports. For any two endpoints to establish a connection, they must use ports. All right. Now clients connect to a defined port and expect a response on a FREL port. Different operating systems uses different port ranges. Now if you look here, there is port number 50105, and if it is a web server, the port is 443. The request is on a different port and the response is on a different ports. Now how NACL will work with ports? You see, we can add these ports either to inbound or outbound. Basically, if you add these ports, then the communication can be established. Now if you see this, the port number of Amazon RDS is 3306. Now allow outbound TCP on port 3306. That means the communication will be established. That is how we can use the NACL with the ports. And we can also create NACL rules for each target subnets as well. Now we also have something called as security groups, right? Now what is the difference between a security group and a NACL? Now a security group operates at an instance level. NACL operates at a subnet level. Okay, security group operates at a instance level. Each instance will have one security group. Now it supports allow rules only, supports allow rules as well as deny rules. So a security group, we will only add rules that are to be allowed. But NACL, we can allow also. We can also say create a rule and we can say deny this rule. And it is stateful. Security groups are stateful and NACLs are stateless. All rules are evaluated before deciding whether to allow traffic in a security group. Now in NACL, rules are evaluated in order when deciding whether to allow traffic, first match wins. In a security group, applies to an EC2 instance when specified by someone. An NACL automatically applies to all EC2 instances in the subnet that it is associated with. Alright, that is the difference between a NACL and a security group. Alright, let's go ahead and create a hands-on demo of creating a VPC and allowing subnet, creating subnets. Okay, let me switch to my AWS console. Alright, this is my AWS console, and if you scroll down, you will see something called as security groups, elastic IPs and all. But let us first go to something called as VPCs. Okay, you see there's an option called as VPC. VPC is virtual private cloud. Okay, in this particular region, which is in Tokyo, there's only one VPC. Let me create one more VPC. Select option create. So when I'm creating VPC, I can also create subnets at the same time. But for the interest of demo, let me create VPCs and subnets separately. Okay, and I'm giving the name of my VPC as a demo. And I want to give a CIDR range for my VPC. Okay, now I'm giving a CIDR range as, let's say, 16.0.0.0/16. That means how many IP addresses are available? 255 into 255 are available in this particular subnet. So many IP address range can be defined here. Okay, now rest all I will leave it as default and create a subnet. Now this subnet is created. Go to your VPCs. This is a subnet that I have created demo. Go to that. Okay, now if we see, there is no other information there except the CIDR range. That is what we have given. There is no subnets and all that stuff. Let us go ahead and create subnets and associate with this particular VPC. Now I am saying create a subnet. For this subnet that you're creating should be part of which VPC? I'll say that should be part of a demo VPC. Okay. And what is the subnet name? I'll say my first subnet for demo. Okay, some random name. You can choose availability zone preferences. If you don't choose, AWS will automatically choose that. Okay, now what should be the IP address range? Now let's say if I'm giving an IP address range 14.0.0./24. Okay, will it accept this? Let us go ahead and see create subnet. It is not accepting because for the VPC, what is the subnet range that we have given? We are given starting with 16.0. That means all the VPC address ranges starts with 16.0, right? How can I give 14.0? It is not possible. Let's say I would give 16.0. Maybe I can give /1 24. Okay, let me go ahead and create. Okay, I'm able to create a subnet. Okay, you see my first subnet demo is created. Let me create one more subnet in the VPC called as demo, and the subnet name is my second sub. The IP address range is 16.0.0. I'll use 2.0/24. This is also allowed in that particular VPC range. Now create a subnet. Okay, now two subnets are created. Okay, now let's say, let me select this subnet, second subnet. Okay, now even before that, let us go to internet gateway. So we have to assign an internet gateway to the VPC. So this VPC, is it having any internet gateway? There is no internet gateway. Let me create one internet gateway. Create an internet gateway. Say demo IGW. Create internet gateway. Okay. Now status is detached. If you see the internet gateway status, it is not assigned to any VPC. Go to actions, attach to a VPC. Now select a VPC. Demo is the VPC that I want to attach the internet gateway. Select option, attach internet gateway. So till now we have created a VPC, we have created subnets, and we have created internet gateway and attached an internet gateway to a VPC. All right. All right. These are the three hands-on exercises that we have created. We created a VPC, we created subnets, we created internet gateway, assigned the internet gateway to VPC. This is what we have done till now. Now let me recap what we have discussed till now. Till now we have discussed about VPC. We discussed a couple of factors about default VPC. We understood about NACL. We understood about couple of terminology on VPC like internet gateway, subnets, CIDR, and we discussed about difference between security group and NACLs. All right. I strongly recommend you guys to go through this document and do the hands-on exercises. We will cover the next exercises in the next video. You guys have a good time. Take care.